We're solving problem 21 from the 2018 F equals MA exam A. A ping pong ball, a hollow spherical shell, with mass m is placed on the ground with initial velocity v0 and 0 angular velocity at time t is 0. The coefficient of friction between the ping pong ball and the ground is mu of s is mu of k is mu. The time the ping pong ball begins to roll without slipping is, and we need to find said time. So we know there's a frictional force acting against it. So in order for it without slipping, we need to account for the frictional force. So we have F sub F is equal to MA. And then from this equation, we also know that F sub F times R is equal to inertia times alpha in this case, or 2/3 R squared times alpha. Now we know that the angular frequency omega is equal to alpha times time, which is you solve for alpha by dividing this by that to get 3f sub f over 2 r d, and that's what you get for omega. Now we need to remember that f sub f, the friction, is equal to mu mg, and velocity in an angular frequency scenario would be r times omega. Thus, we have velocity 0 minus mu gt is equal to 3 mu g over 2 times t. Velocity 0 is then 5 mu g over 2 times t. So time t will be equal to 2 v0 over 5 mu of g. So that is our answer, and is answer choice A on the test.